So I'm going to show you how we can do these in Desmos. If we can do them in Desmos 3. So for this one, we can do this a couple different ways in Desmos. One is we could put in the expression as is, but instead of lowercase x's, use capital X's. And then I'll ask for a slider. If I add in that slider, I can make that value -3. And it would tell me my answer is 3. So you could do it that way. You could use the same expression but put in different variables, not x or y, but something else, lowercase, and then it would do the same thing. You could also put in -3 in parentheses, where every time you say an x. And that would also give you the correct answer. So either way, the answer was 3. If you are doing it this way, you could just say it did work in Desmos. Questions on that one? Number 4, I could also do that one in Desmos. By putting the points in. And as I'm looking at the points, if I were to count the slope, I see that both of these fall on the same line, so there is no rise, there's only a run. So that means there would be a horizontal line going through this, which means this would have a 0 slope. And number 5, you really don't need Desmos because we can start at this point -2/4 and use our slope -2/3. So go down 2 to the right 3 as many times as possible. And graph your line. And the lower. So as long as you have a point and a slope, you can graph anything. You don't necessarily need to know what the y-intercept is because it didn't ask for that. But if you wanted to check yourself in Desmos, you would put in the point. You would put in the point -2/4. Put in your y equals mx plus b. Add all sliders. Change the slope to -2/3. And then either hit play or move this until it goes through that point, which happens to be at a decimal, 2.7. And that would show you that your line that you graphed matches this. Questions on any of the, I was going to say decimal, and then I was going to say decimals, shark bites. So look at your course calendar really quickly and take note of some important dates. This unit, like the remaining units, are going to move fast. We got to get through a bunch of stuff before you guys take the SOL. You guys are only going to test 2 more times before the SOL, and then the remaining tests will happen after the SOL. More on that later. I don't know exact dates for the SOL yet, still waiting on that. So this unit has 4 objectives, and we are set to quiz on for this really hard to see. The 20th, so in a couple weeks, and then test that same week on the 22nd. 23rd, yeah, whatever that date is. Okay. So keep that in mind. If at any point in time you are struggling, have questions, you need to come see me after school if there's not time in class to ask specific questions. Take note of those math dates. There are 2 that are due this week for what we're going to cover today, and then a bunch due next week. If you use your course calendar often, you may also want to put that on Tuesday, your first SOL A1, those problems are due. And then on Tuesday, I will tell you what the next section are and when those are due. I will also start updating it in Canvas. I just have not done that. Any questions about any of the dates, upcoming dates? So this unit is on inequalities. Some of this stuff you will have seen before, some of it you will not. So make sure you have your notes in front of you. There are 2 rules you need for when graphing inequalities. One is use an open circle for less than or greater than signs. And then use a closed circle for less than or equal to or greater than or equal to signs. So if we had something like 1 through 4, they were already solved and we got this and we had to graph it. For number 1, we would start at positive 3. Would this be open or closed? Open. At 3, going to the left or to the right?
The left.
To the left. So if you're not sure, you can pick any number and replace it with x and see, is this true? So if I picked 0, 0 is less than 3, so that's the direction I need to go. But if you pick like 8, 8 is not less than 3, so that would not be the direction you would be going. This shows you all of the solutions that are possible for an inequality. So everything less than 3 could work. Okay. For number 3, at 7, would that be open or closed?
Closed.
Closed. Going to the left or to the right? To the right. Everything greater than or equal to 7. Then in 5 through 8 is doing the opposite. So now we have graphs and have to write the inequality. So like for number 7, it starts at 0, and we know it's closed. So that's either going to be less than or equal to or greater than or equal to. Which one would it be? Less than. Less than or equal to, because it's going to the left. Most of the time, the direction it's pointing is the direction it's graphed, and vice versa, but not all of the time. I'll show you some examples where that's not the case. Number 8, this starts at negative 3. It is open, so strictly less than or strictly greater than. Which one would this be? Greater. Questions on how we write or graph inequalities on a number line? Now we're going to get into the solving piece. Another rule we need for solving inequalities, you must flip the inequality symbol when you multiply or divide by a negative number. So I'm going to give you a couple examples. So let's say I have some negative 4x is greater than 4. If I were to solve this, I'd have to divide both sides by negative 4. And when I do that, because I'm dividing by a negative, the sign is going to change direction. if I had something like 4x is less than negative 4, and I divide both sides by positive 4, the sign will not change. So if what we're dividing by, the coefficient, is negative, then you change the sign. But if you're dividing and the other part is negative, you don't change the sign. So keep that in mind. Questions about that before we get into the solving piece? Okay. The main thing about solving inequalities is that you solve it the same way you would solve equations, just keeping your inequality rules in mind. So how would we solve number 9? Subtract 2. We have 3x is less than negative 6. And then, to solve this, divide 3 on both sides, correct? And then when we divide, does the sign change? No, it stays the same. Then you have a blank number line. You can put whatever numbers you want there as long as negative 2 is in there. It doesn't matter the order. I like to put negative 2 in the middle and then branch out from there. You don't have to do that. You just need to fill up the number line. Would that be open or closed? Open. Going to the left or to the right? Left. Everything less than negative 2. Do we have any questions, confusions, concerns on how we solve that? Let's start the next one. How would we solve that? We have x over 6 is greater than negative 3. And then to get rid of 6, multiply by 6. If this fraction or the 6 was negative, we would be changing the sign. But because it's not, we're not. So x is greater than negative 18. Go ahead and fill up your graph. Would that be open or closed? Going to the left and to the right. To the right. Everything greater than negative 8. When you finish that, go on to the next page. So not only do we need to know how to solve it, how to graph it, write it, but also we need to talk about interval notation. So this is different than us writing this x is greater than 1. It's similar, but a little different, because now we're going to be using parentheses or brackets, square brackets. So we use parentheses if we were to use an open circle, because it means it's not included. We use brackets to mean it's included if we would use a closed circle. And then if it goes to infinity or negative infinity, we would use parentheses. So that doesn't really make a whole lot of sense right now, but once we actually do it, it should start. So with number 1, we can either distribute the 4, or we can divide both sides by 4, since 4 goes in a 24. Which would we rather? Divide by 4, okay. So if we divide both sides by 4, If this 4 had been a negative, we would be changing the sign, but it's not, so don't do that. The 4s are going to cancel, just leaving x plus 3 is greater than negative 6. And then get rid of 3. If you wanted to distribute instead of dividing, you could also do that. We should get the same answer. So go ahead and graph that. Is that open or closed? Open. Open. Going to the left or to the right? To the right. Now, your interval notation, you are looking at this left to right. You're looking at your graph. So you're looking at where does this start? It starts at negative 9. This has a circle and it's open, so we're going to use a parenthesis. And then negative 9. And then we're looking at where does this end. So if this keeps going to the right, where does this end? Infinity. And then with infinities, we always use parentheses. So these two things are saying the same thing. X is greater than negative 9. Your solution is everything greater than negative 9. This is saying all of the solutions start at negative 9 and keep going to infinity. They say the same thing, just in different formats. Questions on how we set up the interval notation? Let's do another one. Number 2, start this by distributing. What would be our next step? Combine terms, the x minus 3x, so negative 2x. Get rid of 6 by adding it. And then when we divide, what happens? The sign changes direction. So x is now less than negative 5. Go ahead and graph that. Would that be open or closed? Open. Going to the left or to the right? Okay, so when we do the interval notation, where would this one start? If this keeps going to the left, negative what? Negative infinity, yes. So this starts at negative infinity. You're always reading left to right. And then where does this stop? Negative 5. It's open, so parentheses. Have any questions so far? Number 3, go ahead and distribute, start solving that. Be careful with your negatives. Is the sign going to change when we divide? No. So x is less than or equal to negative 2 should be our solution, our inequality notation. Go ahead and graph that. Would that be open or closed? Closed. Going to the left or to the right? To the left. So when we do this interval notation, it's going to start off similarly to number 2. So this would start at negative infinity, and it stops at -2. But this time, because this is a closed circle, we're going to use a square bracket. Questions on our notation? Okay. After this one, I'll let you guys choose any you guys want to see done. So go ahead and distribute one more time. Negative 8x plus 8 minus x is less than or equal to negative 28. Combine my terms. Get rid of 8. And what happens when we divide? The sign flips, and this becomes a positive. So x is now greater than or equal to positive 4. Go ahead and graph that. Would this be open or closed? Closed. Going to the left or to the right? To the right. So how would we start writing this interval notation? Would 4 have a parenthesis or a square bracket?
Square bracket.
Square bracket. And it ends at infinity, and that would have which symbol? Parentheses. Always with infinities. Look on the back of that and find any questions you want to see. Do go over numbers 5 through 10. Any others? All of these problems are problems that have variables on both sides. So just like our equations with variables on both sides, you can pick and choose what you want to solve. So what do you want to move? What do we want to move first? Okay. So if we move 2x over, we're subtracting. And then we could also get rid of 20 by subtracting that. So we have negative 21 is less than or equal to 3x. Now, in this case, our x is now on the right instead of the left. I'm going to show you that it still works the same. So divide both sides. The sign does not change. If you can read it like this and still graph it correctly, great. If you would rather see the x on the left, you can take this whole thing and flip it. As long as whatever direction the symbol is pointing to or away from the x, you make it the same. If I take this whole thing and flip it, I'd have x is now greater than or equal to negative 7. These mean the same thing. You could also read this backwards. X is greater than or equal to negative 7. So in this case, if you were to graph this, this would not match the direction of the arrow. It would not be pointed to the left. It would be pointed to the right. So that would be the only case where it's not the same. So that should be closed going to the right. How would we write that interval notation? Bracket, negative 7, infinity, parentheses. Are there any others on this page that we want to see you go over and unless as well? stretch to do that before we switch gears and go on to word problems. This will be the last time we do word problems until we're practicing today as well. These are all the different inequality words that you may see. So as you're writing these down, I'll try to give some examples. Some will be the same or similar. So at least is greater than or equal to. So I could say, if I'm grpahing and trying to make money, I want to make at least $50 today. I mean, my goal is $50. I can make more than that, but I don't want to make less than that. At most is less than or equal to. So that would be, I have at most $100 to spend at the store. I can't spend more than what I have. No more than and no less than are opposites of whatever it says. So no more than is less than or equal to. I have no more than 23 students in here. I have 23, but sometimes I have less. But for you guys, I don't have more than that. More than is just greater than. No less than would be greater than or equal to. I have no less than. Sure. One of the examples I just gave for at least. I want to get no less than 10 papers graded today. I'd like to get 10 done, but if I get more done, that's great. And then less than is just less than. If you see that in an inequality word problem, that is your inequality, not subtracting, unless you see it twice, or you see one of the other words and you see less than. So we're going to do the two that are on the front page. I'll let you guys choose one more from the back, and then you'll have time to practice and work. Alright, so like any word problem, we're going to read through it, find important information, highlight, circle, underline things that are important, define a variable, write an inequality, and then solve it. So let's read the first one. Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 at the end of the summer. He withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? What's important there?
$500.
Mm-hmm.
At least $200.
At least $200.
Withdraws $25 per week.
And what are we looking for?
How many weeks can Keith withdraw money?
Okay, so let's start with our variable. Remember that you can look at your question to find that. How many weeks? So we're looking for number of weeks. We can call that W. And then look for your inequality word. At least is which symbol? See? Not. There you go. Greater than or equal to. What's nice about your inequality word problems is anytime you have an inequality word, whatever number is near it, they go together. So we know this is going to be greater than or equal to 200. Then we have to pick out the rest of what is happening. Operations, withdrawals. Which operation would that be? Subtraction. And then anytime you see the word per, that's going to be multiplication. So we have 500, we have 25, we're subtracting, we're multiplying, and we need our variable. How could we set the rest of this inequality up? $500 minus 25W is greater than or equal to 200. So now we have our inequality. Now we can solve it. So go ahead and do that. And what would we get there? 12. So if he withdraws money for 12 weeks or no more than 12 weeks or less, however you want to word that, he will have at least $200. But if he goes over that 12 weeks, he will not have his $200. If you wanted to check yourself, just like with regular problem equations, you could put 12 back in for W, and then you would be trying to see, is this true or not? So if I put 12 back in here, and I figured out whatever number this is, it would either have to be greater than 200, or it would have to equal 200. If it was less than 200, it would not be true. Questions on how we set up and solve that inequality? Let's try number 2. A taxi charges a flat rate of $1.75 plus an additional 65 cents per mile. If Erica has at most $10 to spend on a cab ride, how far could she travel? What's important there? What else? I'm going to put plus the 65 cents per mile. Yep. And then anything else?
At most $10.
And-
Could she travel?
Yep. We're looking for how far could she travel. So starting with our variable, if we're looking for how far could she travel, that's really distance. And this distance is being measured in miles. So we could call this M for number of miles. At most is which symbol? Less than or equal to. Less than or equal to. So we know that this is going to be less than or equal to $10. She can't spend more than what she has. It says the word plus, so that's going to be plus. And our per tells us we're multiplying. How could we put the rest of this into an inequality? If you switch these two, that's fine, as long as M still goes with 0.65. Let's go ahead and solve that one. You're going to get a decimal. What is that decimal?
Or 7.
Let me more of the decimals. 12.6. 1.
Two.
Okay. with our word problems, we have to see, can decimals, would it be realistic? So like for the last problem, we could have a decimal amount of weeks, like half a week, quarter of a week, 3/4 of a week, whatever. But that was looking for specific full number of weeks. This one, can miles be decimals? Yes. So we can leave it, but we want it exact, so we can put 0.69 or leave it at this 0.692. But that means if she goes over that to 12.7, she won't have enough money. Because it has to be super exact. Do you have any questions about how we set that up, solved it, anything like that for that problem? Look at the back. Find which of those we want to see you go over, have questions about. Chris wants to subscribe to a meal subscription service. Each meal costs $15.99 plus a one-time shipping cost of $9.99. He can spend no more than $100. How many meals could he buy? What's important there? $15.99. I'm gonna highlight the word each meal costs. Highlight the words. What else? No more than $100, and we're looking for how many meals do we buy? So let's start with our variable. What do we want to call it? M, short for what? Number of meals. No more than is which symbol? Less than or equal to. Remember, it's always opposite. If you see more than, do the opposite, and no more than, you're going to have the equal to. So we know this is going to be less than or equal to 100. I was saying that per is your multiplication word, but if you also see each, that's going to tell you we're multiplying. It says plus a one-time fee, a one-time shipping cost that's only going to happen once. How could we set up this inequality? Alright, so let's go ahead and solve that. When we divide, what do we get? It's going to be a decimal again. So it's not in dollars, but 5.6 what? 69. Okay. So if we're looking for number of meals and he's buying he's subscribed to get meals, you're not going to get 0.62 of a meal. So then we have to decide, would we round down or round up? So if you round up, that would be 6. Let's put 6 in here and see what happens. So 15.99 times 6 plus 9.99. What do we get? $105, exactly. 105.93. Is this a true statement? No. So that means we can't do 6, we have to round down. Even though our rounding rules tell us to go up, in this case we have to go down. Because he doesn't have enough money for that 6th meal. Just to double check, go ahead and put 5 in and tell me what that would be.
89.94.
94.
Yeah.
So that he'd have some money left over. It's less than his $100, so that works. So he can buy no more than 5 meals. He can buy 5 meals, but he can't buy any more than that. Otherwise, he will be out of money or owe money. Okay. I meant to ask this for the inequalities piece. I'll hold off on the word problem. But how do we feel about solving inequalities? Good? Okay, need more practice? Not good? I don't understand what we're doing. So for the remainder of class, you guys are going to be practicing. You can either do either of the delta maths that are due on Friday, that multi-step inequalities. Sorry, before you guys practice, I do need to show you one thing. It does know on how to fit yourself. So, but in a moment, you can practice either delta math practices, word problems, or the solving multi-step. You can keep working in the packet of notes. Or you can keep working on your SOL practice that is due on Tuesday. Really quickly, I'm going to show you how you can check yourself with I'm going to go back to the solving equations and inequalities and put in number 10. So when you put in your whole inequality, you'll get something that's shaded like this. We'll talk more about actual shading on graphs in a couple lessons. But you can look at where this line is to see what the number would be, and if it's shaded to the left or to the right, to draw your arrow. This line, we'll talk more about that in a couple lessons, but if it's dashed, that would mean you'll have an open circle. If it's solid, so if I change this instead, if it's solid, then that would be a closed circle. Okay, so you can use Desmos to check yourself as you're going through the problems, work on delta math, SOL practice, or the notes. You can use each other. Let me know if you have any questions.